Hi, everyone. It's Mr. Geiselman here to go over our first real lesson. This is all about our chemistry unit and parts of the atom. So today we're going to be looking at listing the locations, charges, and masses of protons, neutrons, and electrons within an atom. So your job today is to take notes on the Edpuzzle video that you're watching right now, and then you're going to need to attend your hour's live Google meeting after the Edpuzzle. Right, so you should watch the Edpuzzle before attending the meeting. So that's how we're going to go with this. All right, so the first thing we need to do is just a little overview of what is chemistry, because that's what our whole unit is about. So chemistry, by definition, is the scientific study of the composition, structure, and properties of matter and the changes that they undergo. So if you remember last trimester, we talked a lot about matter. That matter is anything that has mass and takes up space. Well, now we're going to look at what is matter made of, how is it made, and then how does it react with other things, or how does it behave when introduced to other things. If we're going to use chemistry in a sentence, you could say in chemistry, we look at the reactions of different substances. So what happens when two different pieces of matter, two different types of matter are introduced to each other. That's something we will look at here in our chemistry unit. So again, just a quick review. What is matter? Well, matter is anything that has mass and takes up space. So it has mass and it has volume. The purest form of matter is what we call an element. And an element is something that we're going to be looking at here shortly. An element has to do with specific matter. If I was going to use this in a sentence, matter is how much stuff or how many atoms are in an object. So if we look at it, matter can be found in three phases that we're going to interact with it, right? There's the solid phase, right? You can think of ice. It's getting cold outside. Ice is starting to form on all of our lakes. Underneath that ice is liquid water, right? So liquid is another phase of matter that we can interact with. And then there's also gases. So those are the three types of matter that you and I interact with on a daily basis. Now, if we start to look at matter and look at its composition and its structure a little more clearly, we're going to see that there's differences in different substances, meaning that there's different elements. And an element, by definition, is a substance that cannot be broken down into a simpler substance by chemical means. So an atom of oxygen is just that element. It is just oxygen. It's going to behave like a whole bunch of oxygen would if introduced to a different situation or a different substance. So an element is the simplest substance that cannot be broken down into anything smaller and still retain those chemical properties. So an element is only made up of one type of atom. So if we had like down here, we had some mercury. Mercury is made up of only mercury atoms. That's a bunch of little mercury atoms there together. Carbon atoms together form diamonds. So just pure carbon atoms together forms diamonds. And then neon there is a gas. And to get neon lights to light, right, we have to pass a current through a neon gas. And that's why they light up with the bright lights. We organize all of our elements onto the periodic table. And that's something we're going to spend a lot of time with here coming up soon. So if I was going to use this in a sentence, oxygen, gold, carbon, and silver are all examples of elements. So what is an atom? By definition, an atom is the smallest particle of an element that retains all of its chemical properties. So one atom of oxygen would react just like 1,000 atoms of oxygen. It just happens to be the smallest piece of it that still will act like that element. And atoms have two main areas. The first area that we're going to talk about is the nucleus. The nucleus is the center of the atom, and it's an extremely dense place, meaning that the pieces of the nucleus are so tightly together, or formed so tightly together, that it is extremely dense. The next piece that we'll look at, or the second area, is the electron cloud. The electron cloud is the outer area that contains what we call the orbitals. You might hear the energy levels, the rings, These are all found in the electron cloud, and they all talk about where one specific piece of the atom is going to be found. If I was going to look at this in a sentence, atoms are a building block for all matter. So nothing on Earth or in the universe can be made of anything but atoms. So here are those two main types. In the center, we have the really dense nucleus, and then surrounding it, we have the electron cloud. And those are the two main areas of an atom. So atoms are really, really small, right? If you had to guess how many atoms would be in a penny, well, you'd probably underestimate a little bit because there's 3.2 times 10 to the 22nd. That means there's 3.2 with 21 zeros after the 2. That's a crazy amount, and that's in a penny. Another kind of example, something that we interact with constantly, like a human body, like your own. How many atoms make up a human body? Well, that number is more like 7 times 10 to the 27th, or 7 with 27 zeros after it. It's a ridiculous number. Now, here's a video that you can watch if you want to learn a little bit more or have another visual representation of how small an atom is, because it's hard to tell from all of those zeros how big that number really is. So if you just Google just how small is an atom, if you have Mr. Oleg, or if you go in our class materials, if you have me for teacher, in our Google Classroom, you can find the slides and you can watch this video yourself. So atoms are made up of 3 subatomic particles. There's 3 pieces that make up an atom. These pieces don't retain the chemical properties on their own, but they are what make up an atom. So there are 3 parts: the proton, the neutron, and the electron. Inside the nucleus, we find the proton and the neutron. Protons and neutrons are represented by the blue and red spheres here in the diagram. And the protons and the neutrons make up that really dense center of the atom, right? The nucleus. As we move outside of the nucleus, we find the electrons. They're moving outside of the nucleus in what we call the orbitals. This is the electron cloud area. And orbitals are kind of the pathways that an electron might follow. When we look at the charges, the electric charge of these particles, the proton is positive, meaning it has a positive charge. Neutrons then are neutral. They have no positive or negative charge. And our electrons on the outside are negative. The charge on one proton is as positive as the negative charge on an electron. They match up really well together. An electron is as positive as an electron is as negative as a proton is as positive. So if we have one proton and one electron, they cancel each other out. Positive plus a negative, right? That's going to give us neutral. So if we have as many protons as electrons, that's going to give us a neutral atom. When we look at the masses of all these particles, they're so small, right, that it's really difficult for us to understand. And that's a really difficult number to work with. So what we did instead is we figured out scientists figured out the mass of a proton and the mass of a neutron, and they figured out it was pretty close to the same. So what they did was they made that mass one atomic mass unit. So when we look at masses of these subatomic particles, instead of saying 0.0 times, with 23 zeros in front of 1672 grams, instead of saying that ridiculously small number, we just say one proton is equal to one atomic mass unit, or 1 AMU. And one neutron is equal to one atomic mass unit as well. So a proton and a neutron are equal to one atomic mass unit. When we look at the electron, it's so tiny that we basically count it as 0. When we're counting up the mass of an atom, we won't count the electrons as part of that, because the electron's mass is really 0.000545 atomic mass units. It's a really, really small number. So we don't even count it when we're looking at the mass of our subatomic particles. So only a proton and a neutron will factor into the mass of an atom. So today in the lesson, you've learned the locations of protons, neutrons, and electrons. You know that protons and neutrons are found in the nucleus of an atom, and the electrons are found outside, orbiting in the electron cloud. You learned the charges of the different particles, so that a proton is positive, an electron is negative, and a neutron is neutral. And then you learned that the mass of a proton is 1 atomic mass unit, and the mass of a neutron is 1 atomic mass unit. And that electrons are so small that we usually don't even count them, and we say that they have 0 mass. If you have any questions, please write them down and bring them with you to the Google meeting. Looking forward to seeing you guys today. Have a great day, everybody.